Hi everybody, thanks for tuning in one more time. This is the third and final video about getting us ready for the test in our 2-3 compaction math class. This will be on this video I'm going to do a couple of things with polynomial functions and using synthetic division to find the roots, and then one other thing that I'll let you know about in just a second. But let's say that you've got this polynomial written out in standard form. Looks pretty hairy, fourth degree polynomial. And your job is to find the roots. However, stay tuned. There's a twist coming at just pretty soon. So you're going to look at the last term, the constant, and think of the factors of that, which are 1, 3, and 9. And then the factors of the leading coefficient, which is 2, are just 1 and 2. So the possible list of rational zeros for this polynomial would be 1 over 1, 1 over 2, 3 over 1, or 3 over 2, 9 over 1, or 9 over 2. So there's our numbers. And by the way, these are all plus or minus. It could be positive or negative, any one of these numbers. Now, what I'm going to do, though, on this test is I'm not just going to have you do that. I'm going to actually tell you what one of the zeros are. So I'm going to tell you, for example, that one of the zeros of this polynomial is 1/2. And you'll either get that just in a statement, I'll just tell you one of the zeros, or you'll be looking at a graph and you can tell one of the zeros is 1/2 or some number, and then the other two zeros are maybe they're irrational, but you can't really tell what they are from the graph. So you're going to have to use the synthetic division process to find the other zeros. All right, so I'm going to tell you, in this case, for example, that one of the zeros is 1/2. So you put 1/2 in your little synthetic division setup here. Here are the coefficients, all right, of all the terms in the polynomial. And we start the process by bringing down the first term. Always bring this down unchanged, so 2 becomes 2. Now I start multiplying. 1/2 times 2 equals 1, and I write the result right there underneath the -11. Now I add. -11 plus 1 is -10. All right, now we start doing that all over again. 1/2 times -10 is -5. I write that up there underneath the next term. I add down. 11 and -5 is 6. 1/2 times 6 is 3. And so 15 plus 3 is 18. And 1/2 times 18 is 9. And sure enough, just like you were hoping, you got a 0 for this. Now, what that means is you still have to find some more zeros, but now we can use these numbers here instead of the original 5 numbers from the polynomial. All right, so we've got a little bit less work to do, having found already 1 0. So I'm still looking at numbers from this list right here. Okay, and so let's see. So now it's kind of guess and check. So I'm just going to pick one here. Let's say I pick -1. I don't really know, so I'm going to try -1. I bring down the 2 again. 1 times, or -1, so that's -2. I got -10 plus -2 is -12. Times -1 is +12. I bring these down, I get 18. And -1 times 18 is -18. Oh goody, I got another 0 right away without too much guess and check. You know, you have to resign yourself. Sometimes it takes a while to find these other zeros. You may get lucky like that, like I just did, or you may try some of these other numbers for a while before you find one. But what we've got now is good, because this is a quadratic quotient. Remember, we started with a 4th degree. This result right here, when we found that 0, this is a 3rd degree, and this is a quadratic quotient, meaning that this 2, -12, 18 represents the polynomial 2x squared minus 12x plus 18. So now I have to find the zeros of this. And it's possible that we can factor this. And I would try first off factoring out the 2 just to kind of reduce the numbers by a little bit. So that would be x squared minus 6x plus 9. And I am pretty sure that I can factor this because it looks like a perfect square thing here. 3 and 3 and 6. And if it's -3 and -3, Okay, negative 3 times negative 3 is positive 9, and when I add those numbers, I get negative 6. So these are the factors. So I was given this root of 0, I'm sorry, a 0 of 1/2, excuse me. I was also given, and then I found negative 1 is the other 0, and now my other two zeros are positive 3 and positive 3. And so the roots, or the zeros of this polynomial, whichever you want to call them, are 1/2, negative 1, 3, and 3. Now you may be thinking, why do I have to list the 3 twice? Well, first off, it's not very much work to list it twice, but the other thing is that it tells me that you know that there are in fact 4 zeros for this polynomial of 4th degree. So there are 4 zeros. It just so happens that 2 of them are the same. So you're leaving no question about the fact that you know what all 4 zeros are for this polynomial. Okay, so that's a little bit of the synthetic division process. There's an element of guess and check involved. It's unavoidable in this process, but I'm going to help you kind of take some of that out by giving you a polynomial, and I'll tell you what one of the zeros is, and you can use that in your synthetic division process to find the others. Okay, now the other thing that I wanted to go over in this little video with you is how you take a polynomial written out in factored form and change it into standard form. Now, that's not a very mysterious process. It's just a little tedious, but I'm finding that a lot of us don't have a good strategy for multiplying a lot of those things together. So, first off, when you are going to change this factored form polynomial into standard form, you do have to multiply everything out. There's no way around that. But we can be smart about it, and you should always think of just multiplying 2 things at a time. Don't try to multiply 3 or 4 things together all at once. You'll just get totally confused. So this is x minus 3 squared. Let's figure out what that is just right off the bat, okay? X minus 3 squared is going to be, sorry, that looks like a negative sign. I don't want to have that there. X squared minus 6x plus 9. That kind of looks familiar. I think that just showed up in the last problem that we did, as a matter of fact. Okay, so that's what this is right here, multiplied out. Now, I want to multiply these 2 things together, and that's going to be another trinomial. So I got x times 2x is 2x squared. X times 3 is 3x, and then I've got a 2x times 1, so 3x and 2x is 5x. So that's going to go in the middle, and then 1 times 3. Okay, so now I've got this trinomial times this other trinomial. Now there's several different ways to do that, so let me show you one strategy. Maybe I'll even show you 2 if we have enough time. But one strategy is to use a kind of a generic box approach. They call it in math teacher lingo the area model for multiplication. But what it means basically is to write one of the polynomials, and I'll just pick the first one there, as the side of a box. And then the other polynomial will be the other side of a box. And so that's 2x squared, 5x, that's plus 3, and 3. So now my box will have actually 9 different little subdivisions in it, okay? And all I'm going to do is multiply each pair of terms and fill in each box, okay? So it takes a bit of work, but we'll get there. 2x squared times x squared is 2x to the 4th. 2x squared times negative 6x is negative 12x to the 3rd. 2x squared times 9 is 18x squared. Okay, let's do the next line. 5x times x squared, that's 5x to the 3rd. And 5x times negative 6x is negative 30x squared. And 5x times 9 is 45x. All right, last line. 3 times x squared is 3x squared. 3 times negative 6x is negative 18x. And 3 times 9 is 27. So what's nice about this arrangement is that it sort of lines up all your like terms that you are going to have to combine. Like these 2 here both have the cubed x to the 3rd power. In this diagonal row are all the squared ones, and then in this diagonal row are all just x to the 1st power. So we've got all of our like terms kind of, lined up for us to combine. So this all equals 2x to the 4th Okay, now let's just add these together in our head. 5 and negative 12 is negative 7. So it's minus 7x to the third. And then these three things here, let's see, I've got 21 and negative 30 makes negative 9x squared. And then negative 18 and 45, I believe that's 27. So plus 27x. And then 27 plus 27. So that's my polynomial in standard form. If I multiply all that stuff out, it equals this. All right? Just to show you that, to give you another idea for multiplying polynomials together, if you had to multiply this times this, okay? Another way to do that, and this is a pretty nice method. You might actually like this, and you might have never even seen it before. I'm going to take x squared minus 6x plus 9, and I'm just going to write the next one right underneath it. 2x squared plus 5x plus 3. And in the same way that you used to when you were in elementary school, let's say multiply, 153 times 16, right? You multiply those together, you go 6 times 3, 6 times 5, 6 times 1, and you write that answer here, and you put a 0 for the next line, you go 1 times 3, and you do all that stuff, and then you add up your terms. You remember that little process for multiplying numbers this way? It works the same way for polynomials. It's kind of cool. If I just, I'm sorry, not plus, I'm multiplying. So 3 times 9 is 27. 3 times negative 6 is negative 18x. 3 times x squared is 3x squared. Okay? Next line. 5x times 9 is positive 45x. 5x times negative 6x is negative 30x squared. And then 5x times x squared is 5x to the third. And then finally, the last one, 2x squared times everything, I'm going to put 2 zeros. 2x squared times 9 is 18x squared. 2x squared times negative 6 is negative 12x to the third. And 2x squared times x squared is 2x to the fourth. And in the same way, I'm adding up all these like terms. And you can see they're all right here in the box. Here's the 5 and negative 12. There's those two. Here's the 3, negative 30, and 18. There they are. Here's the 18 and 45. So it's all still there. We still get the same thing. It's just a different way of arranging all of these little multiplications that you have to do in order to multiply these big old polynomials together. All right, so a couple of different strategies there for you. I hope that helps, and I hope that these videos are helpful to you. I hope your health is good and that all is well in your life, and just take heart. Everything will be okay eventually. Bye.